Good morning. This is the fourth unit of this subject of statistics, and in this unit we will talk about distributions of random variables. In this first video I will talk about discrete variables, probability function. So what are the types of random variables? According to the nature, we can talk about qualitative variables or quantitative variables. For example, I can have information about the color or the brand or the sex from one individual. Obviously it is qualitative information, but we can code with numbers. Quantitative means when we have a physical magnitude measured in numbers, so the information is expressed in numbers. So also regarding the number of characteristics, we can have one-dimensional variables, or we can have two-dimensional variables, three-dimensional variables, or in general k-dimensional variables. And also regarding this set of values, we can have discrete variables or we can have continuous variables. Continuous is in the case that values are measured with decimals. Every time that I have a value expressed or measured with a few decimals, it corresponds to a continuous variable. And what is a discrete variable? Okay, well, discrete is when the sample space is formed by a finite number of values. For example, when I throw a die and I record the points that I obtained with every throw of a die. It can be a value from 1 to 6, so these values are discrete. Or it can be what is called numerable infinite. For example, number of throws of a die until obtaining the value 6 for the first time. The minimum value is 1, but there is no an upper boundary. Of course, it cannot be infinite because sooner or later I will get the value 6. But I cannot establish an upper boundary, and for that reason we call it a numerable infinite. Okay, so these values are usually the result of counting something. Okay, for example, number of defective pieces in a sample. Imagine an industrial process. I can take a random sample, and in that sample I can count the number of pieces that are wrong or have some kind of problem. I count, so this is a discrete variable. Or I can count the number of readings in a diskette until it fails. Okay, never with decimals. Every time that I count something, it is nonsense to express these values with decimals. Also, the case of discrete variables can be the result of coding something. For example, I can have the information about the sex of an individual, and I can code it as a man or a woman. Obviously, this is also a discrete variable. Or I can have supplier. I can code supplier A with the value 1, supplier B with the value 2, supplier C with the value 3, for example. Okay. So, one important definition. We define as probability function, also called mass function, the probability that the random variable takes every possible value. Okay, this is what we have here. I will try to explain with one example. Okay, so this is the definition of the probability function. Okay, so let's explain this with this example. Number of vehicles that are stopped in every cycle of a traffic lights. So imagine that I'm just next by a traffic light. Every time that it is red, so I count the number of vehicles that are stopped, then the traffic lights become red, the cars go by, then again they become red, and then again I count the number of vehicles which are stopped. So imagine that this is my experiment, so I have carried out the experiment several times, and this is the number of vehicles that I have counted. So here I can put the values that I have measured, okay, and then I count what is the observed number of data. So for example, the value 0, this is just once, okay, so here the number of data observed, it is just 1. the value 1 appears 1 and 2, so twice. This value appeared twice, so here I put value 2. The number of 2 appeared 1, 2 and 3 times, so here I put that the value 2 appeared 3 times, and so on. So this is absolute frequency. If I sum the absolute frequency, it means that I have 10 values. Okay. Then here I can calculate the probability function. Okay, so the value 0 appeared once over 10 values, so the probability is 0.1 or 10%. The value 1 appeared twice out of 10 values, so the probability is 20%, and so on. Okay, so if I relate the values x with the probability of every value, this is called the probability function. Okay, well, this could be an example or an exercise that we can put in the exam. Okay, so we can provide some values like that, and the question would be obtain the probability function. That would be one example. But another possibility is that here I can represent the probability that the random variable is lower or equal than the every value. For example, the value 0. What is the probability to having observed a value of 0 or less than 0? Well, just one value. So the probability is 1 over 10, which is 10%. What is the probability of having observed a value of 1 or less than 1? So we have 2 plus 1, which is 3, 3 over 10, so this is 0.3. The probability for 2, so less or equal than 2, this is 3 plus 2 plus 1, which is 6, so 6 over 10, this is 0.6. So we are accumulating the different probabilities, okay? So this has a different name. It is called distribution function. And an important thing is that the probability function is just defined for discrete variables. But important, the distribution function can be applied for discrete variables, or also the same definition applies for continuous distributions. Okay. Then the probability function models the pattern of probability of discrete variables. And this is the definition. Okay. And as I was saying, it's important the notation. When we represent capital X, it refers to the random variable. When we put lowercase x, it means a particular value of the x. Okay, so this is important to understand what we mean when we put this expression. Okay, for example, in the previous slide, the number of vehicles stopped in a cycle of the traffic lights. Okay, so this is the example. So now let's think about how to represent graphically this probability function. So the way is like lines or bars like this, or with points. Okay, one point here, another point here, and so on. But that would be wrong to represent like a line or like a curve. No, that is wrong. Why? Because the function is not defined for values between 0 and 1. So for 0.5, it's nonsense to define the probability function. It is just defined for 0, for 1, and for 2. Okay, so this is why we represent like lines or like points, but never with a curve or something like that. So an exercise. Think about the points obtained by throwing one die. What is the probability function? Well, that could be an exercise for you as students. You have to think what would be the shape of a block like this one. Okay, well, in this case, obviously the probability of every value is the same, 1 over 6, and then the sequence of points will be like horizontal. Okay, then let's think about a different exercise. We have two dice like this in the picture. We throw both dice at the same time, and then we sum the values of the points that we have obtained. Then the exercise is obtain the probability function of this sum. So the variable would be the sum of the points from both die. So here this is a matrix that displays the points from one die, the points from the second die, and then we sum. For example, if I obtain 1 and then 1, so it is 1 plus 1 is 2, obviously. If I obtain 1 and 2, we sum, that is 3, and so on. Okay, so the minimum value is 2, the maximum value is 12. Okay, so the range of this sum is from 2 to 12. So we can put this range here. And then what would be the probability of every value? Okay, so the value 2 is just obtained once. So the probability is just 1 divided by 36, because we have 36 possible values. Okay, so we put 1 over 36. The value 3 appears 1 and 2. Okay, so appears twice. 2 twice divided by 36, which would be the probability. The value 4 appears 1 time, twice, and 3 times. Okay, so 3 divided by 36. And so just counting, we get the probability function. That would be the solution. Okay, so here I finished this video about discrete variables probability function. Thank you for your attention.